Let's look at some examples of problem situations that we can solve using quadratic equations. Suppose the function c of t equals negative 0.56t squared plus 18.33t minus 50.9 models the number of subscriptions per 100 people worldwide cell phones t years since 2000. And the function f of t equals negative 0.041t squared plus 0.32t plus 18.7 models the number of subscriptions per 100 people worldwide for fixed telephones t years since 2000. Estimate the year when the cell phone subscription rate was equal to the fixed telephone subscription rate. When it's asking you to determine when two functions are equal, you solve that by setting the two functions equal to each other. So here we would have negative 0.56t squared plus 18.33t minus 50.9 is equal to negative 0.041 t squared plus 0.32 t plus 18.7. Now, because of all these decimals, I can tell that I'm not really going to be able to solve it by factoring, and completing the square would be a real pain. So I'm going to use the quadratic formula for this one. To use the quadratic formula, I need to get all the terms on one side. So I'm going to get rid of all the terms on the left side of this equation. So I start by adding 0.041 t squared to both sides. I'll subtract 0.32 t from both sides, and I'll subtract 18.7 from both sides. This is going to give us 0 on the right side. On the left side, negative 0.56 plus 0.041, we have negative 0.519 t squared, and then it'll be plus 18.01 t minus, let me make sure I calculate this right, 50.9 plus 18.7 minus 69.6. Now we've got everything on one side equal to 0. We can solve this using our quadratic formula. Now the quadratic formula is not really any easier or harder with decimals than it is with other numbers. We still set it up exactly the same way. Negative parentheses, plus or minus the big square root. Under the square root, we have a parentheses squared minus 4 times a parentheses times a parentheses. In the denominator, we have 2 times a parentheses. B is 18.01, so that goes in our first two blanks. A is negative 0.519, so that goes in the next blank and in the blank on the bottom. C is negative 69.6, like so. All right, so let's try to simplify this a little bit at a time. We would have negative 18.01 plus or minus the square root. Now, because I've got all these decimals, I'm not going to worry about simplifying a square root. I'm going to go ahead and use my calculator just to calculate everything under the square root all at once. 18.01 squared minus 4 times negative 0.519 times negative 69.6. Under that square root, I have 179.8705. And on the bottom, 2 times negative 0.519, we have negative 1.038. And then I'll go ahead and calculate that square root on the top. To calculate the square root of 179.8705, it ends up being about 13.4116, just to round it off to several decimal places. Now it could be a plus or a minus on the top. I have to consider both possibilities. So negative 18.01 plus 13.4116 over negative 1.038 and negative 18.01 minus 13.4116 over negative 1.038. On the top, let me calculate that. Negative 18.01 plus 13.4116. Take that answer divided by negative 1.038. Here I get about 4.43. Or since we're finding years, we need to round it to a whole number. We'll just say it's about 4. The next one, negative 18.01 minus 13.4116. Divide that by negative 1.038. Here I get about 30.27. Or again, rounded to a whole number, it's approximately 30. Now T is years since 2000. So to figure out the actual year, I would add each of these to the year 2000, and I get that they would be equal in the year 2004 and in the year 2030. Let's take a look at another example. Here it says a group charters a flight that normally costs $800 per person. A group discount reduces the fare by $10 for each ticket sold. The more tickets sold, the lower the per person fare. There are 60 seats on the plane, including 4 seats for the crew. What size of group would maximize the airline's revenue, and what would be the ticket price? Okay. All right. So to figure this out, the money that they're going to make, the revenue is going to equal the number of tickets sold multiplied by the price per ticket. We don't know how many tickets are sold. That's one thing we're trying to find. We're trying to figure out how many tickets they should have in order to maximize the airline's revenue. So I'm just going to put X for the number of tickets. Now let's think about the price per minute for a minute. It starts at 800 and it's reduced by $10 for each ticket sold. So we would have 800 minus 10 times the number of tickets sold, like so. So our revenue function is X times 800 minus 10X. If we distribute the X, we would get 800X minus 10X squared, like so. It's good when you're thinking about maximums and minimums and so on to go ahead and have the terms in descending order. I'm going to go ahead and rewrite this as negative 10X squared plus 800X. So since the problem is asking us to maximize this, maximums or minimums will happen at the vertex. So let's recall the vertex of a function. The x value of your vertex will happen at minus b over 2a. In this case, b is 800. A is negative 10. This gives us negative 800 divided by negative 20, which is 40, like so. And we can actually stop there. It's not asking what would the maximum revenue be. It's just asking what size group would we need to maximize the revenue. So we would need to have 40 tickets or 40 people to maximize the revenue. The second half of the question, instead of asking what the maximum revenue is, it says, what would be the ticket price? And remember, the price per ticket is 80 minus 10x. So here, when we're writing out what the price is, we can say that our price equals 80 minus 10 times 40. This gives us 80 minus 800 minus 10 times 40, which gives us 800 minus 400. We get that the price would be $400. Okay. If you